Greetings to everyone, wherever you are. Once again, I'm Erisa Wante to take you through online mathematics lectures. Today, we are here to discuss integral calculus, to continue discussing integral calculus. In our most previous lesson, we have talked about partial fractions. We want to integrate by partial fractions, but we cannot go ahead to integrate by partial fractions unless we know how to resolve a compound fraction into its component partial fractions. So last time we mentioned the three rules of partial fractions. Today we want to go ahead and look at the rule of partial fractions concerning denominators, which are quadratic functions that cannot be further factorized into prime factors. So there is a rule that talks about that, and that's what we want to discuss today. So after that, we shall resolve so many compound fractions into partial fractions. Then, if time allows, we go ahead and integrate by partial fractions. Before I go ahead to do that in a minute, let me write down the rules of partial fractions to remind you about what we discussed last time. Quick reminder, these three rules I have so far listed were discussed last time. So there's nothing much I can say about them. But there is rule number 5, which is coming ahead. That's the one we want to discuss today. Then after, we shall use all the rules in resolving, compound fractions into partial fractions. Rule number 5 is about an irreducible quadratic factor. That is a quadratic factor which cannot be further factorized into prime factors. Okay, this will give partial fraction is partial fraction ax plus b over ax squared plus bx plus c. Okay, so how do you tell that a quadratic factor cannot be further factorized? It is simple. Any general quadratic is given by, okay, in a general quadratic is given by ax squared plus bx plus c. Okay, now if b squared minus 4ac, okay, is not a perfect square, a perfect square, then what happens is that we cannot further factorize that quadratic into prime factors. Okay, so always if you want to test and see if a quadratic will factorize, look at b squared minus 4ac. If it gives you a perfect square, then you can factorize. But if you don't get a perfect square, then you cannot further factorize. So if b squared minus 4ac is not a perfect square, then the quadratic cannot factorize. Quadratic cannot factorize. Okay, so that's the testing. That's how you'll be able to tell that a quadratic factor in the denominator is either factorizable or not factorizable. So it is so important. I've just put it as a reminder. So let's look at examples and see if we can try to make use of these rules of partial fractions we have listed. Then after, we shall go ahead and start on integrating by partial fractions. So example 1, we want us to express x squared over x minus 2 into x squared plus 1, okay, in partial fractions. All right, this is not a problem. We examined the 6 rules of partial fractions we have highlighted above and see what to use. So when you look at this question, you discover that it passes the first rule because rule number 1 is about the power of the numerator and the power of the denominator. If we check the numerator here, the power is 2, okay? That's the degree. And then when you check down, this is x squared times x, of course, will be x cubed. So x squared is less than x cubed, okay? So rule number 1 is passed perfectly, okay? Rule number 2, we talk about factorization of the denominator. This factorized, okay? Rule number 3 is about a linear factor. A linear factor, ax plus b, gives partial fractions. Remember that was also discussed last time. So we shall look at the solution here, okay? X squared over x minus 2 into x squared plus 1 will be equivalent to a over x minus 2. The reason is this is a linear factor, okay? Then plus, okay, when you check this part, it is a quadratic that you can't further factorize, okay? You can't break this into linear factors, so it will give you bx plus c over x squared plus 1, okay? So what do we do next? Multiply through by the LCM. Okay, multiplying through by the LCM is the same thing as getting this part. Get this part and multiply it out to everywhere. So you're going to have, you have x squared will be equivalent to a into x squared plus 1, okay, plus b x plus c, okay, into x minus 2. Okay, from this step, we can go ahead and expand and then try to compare coefficients of powers of x squared. You know, we look at the coefficients of xc and then the constant term. But we can easily find the value of a by substituting, by making this bracket 0. What makes x minus 2 0 is if x is equal to 2, because 2 minus 2 will be equal to 0, and the whole of this part will disappear. So 2 squared, what do you get? This is a 4, okay? Will be equal to a into 5, because 2 squared is 4 plus 1, that is 5, okay? Plus 0, okay? Whatever, that will be a 0. So it will mean that, okay, a is equal to 4 over 5. We have got a. Next, we go ahead and expand. I have x squared d is equivalent to, okay, let's look at this critically. I have a x squared d plus a. That's when you open the first bracket. Then when we go ahead and look at this part, we open b x times this, you get b x squared d, then bxc, okay, minus a 2bx plus c x minus 2c. All right, so what do we get here? Let's try to collect like terms. We have x squared d is equivalent to, okay, a plus a b. Those are the only coefficients of x squared, okay? A plus b times x squared. This is x squared. Then what about the coefficients of x? Let's check and see how many x's do we have here. It is just minus, it is a plus c minus 2b, okay, into x. Then the constant terms, we have a minus 2c. Now we are going to equating coefficients of let's begin with the x squared, both sides. We see what happens is the coefficient here is 1, okay? So 1 must be equal. The coefficient here is a plus b, okay? So it means that b will be 1 minus a. But remember, a is 4 over 5, so b is 1 over 5. Okay, to an advanced level student, this is not really a big deal. You can always compute that b equals to 1 over 5. Okay, then I can just look at the constant terms, because when I check the constant terms, I can use n to get the value of c, whether I use coefficients of x and it will give me whatever I want. Okay, constant terms, I will have a minus 2c equals to 0, because on this side we don't have any constant term. Okay, so what does it mean? C, this means that C is a half of A. Okay, but what is A? A was 4 over 5. So C will be 2 over 5. A half of 4 over 5 is 2 over 5. Now we have the value of A, we have the value of B, and we have the value of C. Let's substitute. We can now write that x squared over x minus 2 into x squared plus 1 gives us a, which is 4 over 5 into x minus 2, okay, plus bx. But remember, b is 1, okay? So x plus 2 over 5 into x squared plus 1. And we have resolved this in the partial fractions, so it is really not a big deal. We have done it. Next will be integrating. You can be, told to integrate this function. It's not all that complicated, but for now, let's first learn how to resolve. Then we now bring in the idea of integration. So let's look at this example 2. It is more or less the first example, but it is actually like the first example. Let us see this. Let's look at the solution. So solution, okay, we have been given 15 x squared minus x plus 2 out of x minus 5 into 3x squared plus 4x minus 2. And they want us to resolve this into partial fractions. We first say this is equivalent to. Why do I use equivalent to? Because I don't know the value of a and b, I can't say it is equal to, but if I know the value of a and b, then I can say it is equal to. So you can only say it is equal to after getting the value of a and b. So a, b, and c, rather, let us the constants here. Okay, I'm saying a and b, but the a and b don't even appear. Let's get the constants first. Okay, let's look at this is a linear factor, and the denominator it gives a partial fraction of the form a, where a is a constant, out of x minus a 5, plus this is a quadratic. Let us see if it is factorizable. Get b squared, which is a 4, okay? That is 4 squared is 16, minus 4sc, a is 3, 4 times 3 is 12, times negative 2, that is going to be a 24. So plus 24, this is equal to 40, okay? But it is equal to 40. Now, 40 is not a perfect square. Therefore, that's not factorizable. So we go ahead and write plus a b x plus a c out of 3x squared plus 4x minus 2. Okay, rule number 5 talks about a quadratic which cannot be further factorized. So you make sure these rules are part of your life. Okay, yeah, make sure you get acquainted with these rules so we can continue using them on a daily basis. If you are to be able to solve problems in mathematics, then some of the basics that we use should be part of your life, not just reading something and then just leaving it. It must be part of your life. So what are the values of a, b, and c? Okay. Next, you will want to multiply through by the LCM of x minus 5 and this part. It is always what appears here. Okay. So multiply through and you have 15 x squared minus x plus 2 is equivalent to a into 3x squared plus 4x minus 2, then plus a b x plus a c into x minus 5. Okay, so we can easily get the value of a by substituting what makes this bracket 0. Okay, now we say if x equals to 5. Okay, so if x is equal to 5, let's perform a calculation. 5 times 25, multiply through. So if you go ahead and do the math, you discover that a is equal to 4. That is 372 divided by 93 is equal to 4. Now, we want also to get other constants, b and c, but if you have to get b and c, then we have to multiply and then equate coefficients, compare coefficients of the different powers of x on both sides. Okay, so we still maintain that 15 x squared minus x plus 2 is equivalent to a, which is a 4. I can substitute my 4 into, let me just, without repeating that step, I say 3 by 4 is 12. Okay, or let me keep a. I'll just substitute at the end of it. Okay, so this is a 3a, I think will be plus a b. This is a x squared. Okay, plus, let's go to the coefficients of x. We have 4a, then here minus 5b, okay, plus a c. These are coefficients of x. Then let's go to the constant terms. What are the constant terms? I have plus, I will have x, that is 5, they're all negatives. So it is minus plus, okay, let me write minus 2a minus 5c. Now, we look at, we equate coefficients, equating, okay, coefficients of, let's begin with x squared on both sides and see x squared. Here we have 15, so I have 15 is equal to 3a plus a b. Okay, 15 is equal to 3a plus a b, but I know my a is equal to 4. 4 times 3 you get 12. So what does it mean? It means that b will be equal to 15 minus 12. What do you get? It is equal to 3. Okay, I have the value of b as 3. And if I go ahead and look at the constant term, let me go to the next page. Let's go ahead and compare the coefficients of x on both sides. On this side, we have negative 1 is equal to 4a minus 5b plus c. Okay, but a is equal to 4 and b is equal to 3. Okay, so we have negative 1 equals to 4 times, that is 16 minus 15 plus c. Okay, so what do we get? We get c as equal to, okay, 15 minus 16, that's going to be a negative 2. That's what I'm getting. C is equal to negative 2. We would get the same results by looking at constant terms. If I had decided to use the constant terms, okay, where I have on the other side, I have a plus 2 okay, will be equal to, okay, minus 2a minus 5c. So if you look at this, then we are going to have 2 plus 2 times a, which is a 4, is equal to minus 5c. And you'll end up with the c as equal to minus 2. Okay, so you get the same thing. Now, after getting the value of a, b, and c, we make a substitution, and then we shall have everything we're looking for. Okay, so this means that 15x squared minus x plus 2 out of x minus 5 into 3x squared plus 4x minus 2 gives us a, which is a 4 over x minus 5 plus b is equal to 3x minus 2, bx plus c, but this is negative 2 over 3x squared plus 4x minus 2. And we are done. We have resolved this in partial fractions using the rules of partial fractions. So it is something which is very, very important for any of us. And I think we shall need just 2 more examples. Then we start seeing integration by partial fractions. So I have included an example here, right, just for you, because this looks like 1 and 2. Now, try this out in the same way and see what you get. Now, example 3 is express 18x squared plus 3x plus 6 out of 3x plus 1 cubed. So, this is a law of partial fraction, which talks about a linear factor raised to some power, okay? And if you have to go ahead and try to simplify this, then we shall end up with, let me erase this part. So, okay, now the solution, okay, we know what to do with this kind of partial fraction is always the nature of the partial fractions are determined by the denominator, okay? So this is a linear factor raised to power 3. So this will be equivalent to a out of 3x plus a 1 plus a b out of 3x plus 1 squared plus c over 3x plus 1 cubed, okay? A, b, and c are constants to be determined, okay? So we can go ahead and now determine these constants. Always multiply through by this part. If you multiply through by that part, then you are going to end up with the 18. This is 18x squared plus 3x, okay, I got this wrong there, plus 3x plus 6 will be equivalent to a, okay? So if I multiply 3x plus 1 cubed by this other part, I'll end up with a into 3x plus 1 squared, then plus a b into 3x plus a 1, then plus a c into 3, just that c will have no factor to multiply with because it will cancel out, so just plus a c. Okay, so next, here you cannot use the technique of making the bracket 0. Yes, we can use it and get c, okay, by saying that if x is equal to negative a third, negative a third makes this bracket and this disappear, okay? So we are going to have 8 over 9, 18 divided by 9, okay? That is a 2 minus a 1 plus a 6 will be equivalent to c, okay? Let's try to solve this. Why are we saying 2 minus 1? If you have 18 here, and divide by the square of a third, negative a third, which will be a 9. The answer will be a 2. Then a 3 times a negative a third, you end up with a negative 1. So 2 minus 1, I'm seeing that C is equal to 7. Okay, this means that C equals to 7. Okay, so we have C as 7. Next, we go ahead and expand. Expanding will always be the best, but it takes time because it can give us everything we're looking for. Okay, let's expand this. We have 18 x squared plus 3x plus 6, okay, is equal to, let us expand this bracket. You have a into 9x squared plus 6x plus 1, then plus 3bx, then plus a b plus a c. Okay, so we can go ahead and look at the coefficients of x squared on both sides. We compare the coefficient of x squared. This side I have 18. Let's look at terms having x squared on the other side. It is just equal to 9a. 9a. What does it mean? That a equals to 2. Okay. Then the coefficients of x. What do we have on this side? We have 3 is equal to the coefficients of x here. You have 6a, okay, plus 3b, okay, 6a plus 3b, right? Now, substitute for a, because we're now looking for b. We have c, we have a, okay, we shall end up with 3 minus, remember, a, we are getting 2. 2 times 6 is 12, okay, will be equal to 3b. And 3 minus 12, you get negative 9. Divided by 3, it means that b is equal to minus 3. So we have resolved into partial fractions because I have the value of a, value of b, value of c. What I'm left with is just coming to this step here up, and I write a as a 2, okay, I write here a as a 2, then I write b as negative 3, then I write c as 7, and I'll be done. But let me go to the next page and write this over for you. Look at this question. It is express, okay? They want us to express this part in partial fractions. Okay, that's what they wanted to express in partial fractions. That I have just written it down because it is going to, help us solve the next problem. But this, I'll not do it for you. Why? Because the denominator is only having linear factors. So maybe I will help you write it down. I just write 10x squared plus 7x minus 4 out of x minus 2 into x plus 4, then x minus 1. This is equivalent to a over, because this is a linear factor, the nature of the partial fraction is x minus 2, then the nature here, the type of the partial fraction is b over x plus 4, then minus plus c over x minus 1. So go ahead and find the value of a, b, and c. Remember, the technique is multiply through by the denominator here. It will give you whatever you want, okay? Next is this question I want us to solve. It is about partial fractions, but it requires us to do some factorization. Look at example 4. They are telling us to determine the partial fractions of whatever they are giving us here. Look at this question. It is closely related to what I've written down here, up here rather, okay? But we have a task of factorizing this other part, okay? The task we have is to factorize x cubed minus 4x squared plus x plus 6, okay? And we see if it can further factorize into other prime factors. Let us do that. The moment we can do that, the question is just simple it will be simple for everyone. So we begin by factorizing the denominator. Sometimes using a calculator, can help us to find the roots of, x cubed minus 4x squared plus x plus 6. But we only use it to find the roots and then go ahead to use long division. Okay. Now, here I'm not using a calculator, but by try and error, I have seen that, okay, not only try and error, but also by experience, is that if x equals to -1, okay, x is equal to -1, then I will have -1 minus 4, okay, minus 1, that's already a -6 plus 6 is equal to 0. Now, this means that x plus 1 equal to 0 is a factor, okay? So if x1 plus 1 is a factor, then life becomes simple because the next step will be going to long division, okay? Let's go to long division here. And we divide x, oh no, written so close, I'll not be able to divide. Let me first erase this. So let's go to long division and we divide x8. Oh, no, not, oh my God, I think I'm tired. So we get x cubed minus 4, x squared plus x plus 6, and divide this by x plus 1, okay? X cubed divided by x, you get x squared, okay? Multiply, this will be x cubed, okay? Plus x squared. Now subtract, you will have minus 5 x squared plus x plus 6. Divide minus 5x. So this is minus 5x squared minus 5x. Subtract, you end up with 6x plus 6. Divide, this is plus 6. So this is 6x plus 6. And then 0, 0. Okay, so what does it mean? So far we have x cubed minus 4x squared plus x plus 6, okay? There is no need of this. Is equal to x plus 1 into x squared minus 5x plus 6. Now, what's the task we have still? The task we have is to continue and look at this quadratic. I'm trying to economize space because my pages are almost running out. Now, let's look at this. But, okay, x squared minus 5x plus 6. Can we find two numbers that sums to -5 and have a product of 6? Both numbers must be negative, and that is -2 and -3. So this is going to be x minus 2 into x minus 3. And therefore, I have fully factorized x cubed minus 4x squared plus x plus 6 is now in terms of the prime factors, which is x plus 1 into x minus 2 into x minus 3. Okay, so from there we can go ahead and look at the partial fractions and then determine the constants, and we shall be done. So let's do that and call it a day. So after factorizing the denominator, now we can start this is equal to x plus a over x plus 1 plus a b over x minus 2, then plus a c over x minus 3. And getting the value of a, b, and c is left out as an exercise for somebody who is consuming this for academic purposes. So if you are just there trying to sit down and listening, it is now time you wake up and do something for yourself. Okay, now let me give you some exercise. You try out these numbers on your own, to test your understanding. Okay, then in our next lesson, which is going to be lesson 8 rather, we shall now start integrating by partial fractions.